Hey everyone, where's the math in this problem? Let's begin with this blue right triangle ABC. This is a 3, 4, 5 right triangle. Then we draw this yellow semicircle O, and it intersects the blue right triangle at points D and E, and it is tangent to side AC at this point, tangent to side BC at this point as well. We would like to find what is the length of segment EA, which is this short distance here. You can pause the video and see if you can solve this math problem. Now let's solve this problem together. Let's begin by constructing these two radii, radius OF and radius OG. Since BC is a tangent line to the semicircle and OF is a radius, there's a property that says that the radius is perpendicular to the tangent line at the point of tangency, and so we have here a right angle. Similarly, OG is a radius and AC is a tangent line, therefore angle OGC is also a right angle. So we have here a square. So let's label this as the radius R. This is also another radius R. And all the other sides are also R because we have a square. Now, OE is also a radius, so that is also R. Then finally, for the distance EA, let's assign the variable x for its length. We would like to find what is the length of that line segment EA, which is equal to x. Next, let's consider triangle OBF. And this pink triangle is similar to the big triangle ABC because angle B is common to them. We have here a right angle and we have here another right angle. And this angle here is congruent to this angle because OG and OC are parallel and AB is a transversal. So we now say that these two triangles are similar triangles. And when two triangles are similar, their corresponding parts are proportional. And so we can now form the proportion. This side BF over side OF is equal to side BC over side AC. But what is the length of side BF? BC is 4 and FC is R. Therefore, BF must be 4 minus R. OF is R, so over R. That is equal to the entire length of segment BC, which is 4, over the length of segment AC, which is 3. So we now have this equation. Multiply both sides by 3R, which is equivalent to doing cross multiplication. We have 3 times the quantity 4 minus R equals 4R. Distribute the 3 to the binomial 4 minus R to arrive at 12 minus 3R equals 4R. And add 3R to both sides of the equation. And finally divide both sides by 7 to get R equals 12 over 7. Let's remember this result. Next, from the same similar triangles, let's form the proportion BO over OF equals BA over AC. So we now have BO over R equals BA, which is 5, over AC, which is 3. Then doing the cross multiplication again, 3 times the length of segment BO equals 5R. And dividing both sides by 3, we have BO equals 5R over 3. And let's remember that result as well. Now, look at segment BA. That is composed of 3 parts. That is, BA is equal to BO plus OE plus EA. But BO is 5R over 3, OE is equal to R, and EA is equal to X. Multiply both sides of this equation by 3 to arrive at 15 equals 5R plus 3R plus 3X. And then combine like terms, 5R plus 3R equals 8R. And solve for X. We subtract 8R from both sides of the equation and divide by 3 to arrive at X equals 15 minus 8R over 3. And since we already know that r is equal to 12 over 7, then we can now find the value of x, which is the length of segment EA that we would like to find in this problem. So applying the symmetric property of equality to put x at the left side of the equation, and substitute now 12 over 7 for r. Here's the result. Then to simplify the numerator, the lowest common denominator is 7. So 7 times 15 is 105. 8 times 12 is 96. And then multiply by 1/3 to get 3 times 7 equals 21. And 105 minus 96 is 9. Copy over 21. And reduce the lowest term to arrive at x equals 3 over 7. So we now know what is the value of x. X is equal to 3 over 7 units. That is now our final answer. And that is where the math is. Thank you very much, and we hope to see you again in our next video. Bye for now.